Hello student, the topic that we are going to learn today is complex numbers. So yeah, complex numbers. So first of all we need to know that what are the topics that we are going to study in complex number. Now first of all we will be learning what are the definition of a complex, what exactly a complex number is. Then we will be learning a few operations on complex number that includes addition, subtraction, multiplication and division of complex number. Okay, then we will be learning conjugate of a complex number, and finally we will be learning modulus of a complex number. So let's get started. Okay, first of all, as it's written here that a complex number is a number that can be expressed in the form of a plus b iota, where a and b are real number and I is the imaginary unit which satisfy the equation I square equals to minus 1. In this expression, a is called the real part of the complex number and b is called the imaginary part. Now, in order to write a complex number, this is basically how we write a complex number in general, a plus b iota, where we say that it's a combination of both real and imaginary number. Okay, imaginary number or imaginary part. Now it's written that a and b are real but I is the imaginary unit. Now if I is associated with any real number, or as you can see that when this number itself is concerned, a is the real part, okay, and this is the imaginary part of the number, and both combining together forms a complex number. Now why we say that this only is imaginary part? It is because I is represented for imaginary unit. This small I is actually represented for imaginary units or imaginary numbers. So if it's associated with b, it's written with b, so we say that in this number a is a real part and b is the imaginary part, since iota or I is written with this number which is real, but since it is imaginary unit just because it's written with a real number, so we say that this is the imaginary part of the number and this is the real part of the number. Okay, and combining both real and imaginary part of a number gives you a complex number. Okay, now the general definition for iota is equals to under root of minus 1, and this is the main thing that we need to know so that we can solve further when it comes to operations. Okay, now we will be learning that what is the addition of complex number. Now if we need to add two complex numbers, see, numbers are real or complex. If we talk about they have certain operations, right? They have addition, subtraction. Let's say real number has addition, subtraction, multiplication, and so as the same thing, the same basic operations all these basic operation follows complex number also follows such operations. So that, but there is a way of doing addition and subtraction for these complex numbers. Now first of all, if we are these are the complex number. I have written everything in general. Now in order to, if there are two complex numbers written, okay, and I need to add those two complex numbers, so the thing is that we will be adding by when addition is concerned, we will add imaginary part to the imaginary part of the other number and real part of first number to the real part of the second number, right? As you can see that, let's suppose a plus b iota is any number, is in any general imaginary a complex number, I'm sorry, and c plus d iota is also a complex number. So this is the first complex number. Since it is a combination of both real and imaginary part, okay, a complex number is a combination of real and imaginary numbers, so a plus b iota, and there you have c plus d iota. Now in order to add these two numbers, what I'm going to do is that I'm going to take the real part of this number and the real part of this number, and I will be adding them together, and I will be following the same thing for imaginary part. Now what we are doing out here is we're just adding real to real part and imaginary to imaginary part. Okay, now just let's take an example. Let's suppose we need to add two complex numbers, right? 3 plus 2 iota, and the second number is 1 plus 7 iota. Now how to add these two numbers? As I said that okay, let's just first say that 3 is the real number of real part of this number, and 1 is the real part of the second number. 2 iota is the imaginary part of this number, first number, and 7 iota is the imaginary part of the second complex number, right? So now, okay, now if I am adding this, as you can see what I have done, I've added 3 plus, since we are adding 3 plus 1, which gives you the real thing. Okay, 3 plus 1 is 4, and 2 iota plus 7 iota, which gives us 9 iota. So this is how you add a complex number. You add real part to the real part, and you add imaginary part to the imaginary part. Now moving on, if you wanted to subtract two complex numbers, so how we will be subtracting them? Now a plus iota b, let's say, is the first number, and the other one is the second number. Now this is the general formula given. Okay, if this is the general formula. Now the same thing goes for addition. The same thing goes for subtraction as well. Like in addition, that only real part of first number, let's say this is my first number. Okay, this is my first number. The first number a plus iota b, this is the second number c plus iota d. It doesn't matter if you write it as b iota or iota b. Okay, so it's the same. What I'm going to do out here when I'm following subtraction, I'm going to subtract real from real and imaginary from imaginary. See, a minus c. Okay, out here as you can see that the main common sign is plus iota. Why? Because I've taken iota as common. Okay, and b minus c. Plus into minus is minus, so b minus d. Now let's take an example and understand it better. Okay, see, this is there are my two numbers, right? Now what I did out here is that I just changed its sign. Okay, 4 plus 12 iota, we need to subtract what? Then another number is 3 minus 15 iota. Now how we will be subtracting these numbers? Let's just follow this general formula. It says a minus c, that means 4 minus 3. Okay, plus iota as it is, 12 minus d. Acha, it says b minus d, right? So b is 12 minus, since we need to subtract two numbers, and why I have written minus 15? It's because, see, the number out here, it says, since it in the general formula it was written with addition sign, but out here it's written, it has negative sign associated with it. So the number, the d value is minus 15, not plus 15. Okay, so 12 minus into minus 15, which gives you 4 minus 3 is 1, plus iota as it is, 12 minus into minus gives you plus, 12 plus 15, right? So this is your final answer, that is 1 plus 27 iota. Okay, when we are multiplying two complex number, now how this is done? Okay, now let's say we have two numbers. Okay, what we are going to do out here, we are going to multiply element to element. Okay, now how this thing is done? Okay, when we are saying element to element multiplication, that means this number 3 will be multiplying with 1 first of all, then this number 3 will be multiplying with 4 iota. Okay, following with the signs, this number will be multiplying with this number, and this second number will be multiplying to the second number of the second complex number. Okay, or you can say the imaginary part of the second complex number. So let's get started. 3 into 1 gives you 3, that is 3 ones are 3. Okay, the sign out here is positive, so positive, and now we are multiplying with 4 iota, so positive plus positive gives you what? Positive. Plus into plus is plus, 3 fours are 12 iota. Then okay, see, the sign out here is positive, so plus, and the sign for this number is also positive. Plus into plus is plus. 2 iota into 1 gives you 2 iota, right? And plus into plus gives you plus, so 2 into 4 is 8, whereas iota into iota gives you iota square, right? And since I told you earlier that we all know that since we all know that iota square is equals to minus 1, now what I'm going to do is that I'm going to add these two numbers, okay, which is 12 plus 2 is 14 iota, 3 remains as it is. Now I've substituted value for iota square as minus 1 out here, okay. So this is the value 8 as it is, and instead of iota square I've substituted value of iota square into as written as minus 1 here, okay. Now see, 3 as it is plus 14 as it is, plus into minus gives you what? Minus, so minus 8. The final answer is, see, 3 minus 8 gives you minus 5 and plus 14 iota. So this is how multiplication of numbers are done. Okay, we're taking another example out here. Okay, let z is equals to 2 plus 2 iota and q is equals to 5 plus 4 iota. Okay, now what I have done is that I've asked you to calculate z plus q's. Now out here the main thing is that I have given these numbers a name. Let's say z equals to 2 plus 2 iota and q is equals to 5 plus 4 iota, okay. So z plus q, now I've asked you to add these two numbers, okay. So this is how the addition is done. If I say to subtract q minus z, now this is how q minus z is done. Z minus q, the same thing follows, right? Q into z answer. Now I want you all to attempt and verify your answers, so that it would be a practice for you all, that how these calculations are done. What I've done out here, I've just directly I'm writing down the answers, and I want you all to do it step by step so that you can understand it better how it works, okay. Z into q, q into z. So just moving on. Okay, now we are moving on to the conjugate of a complex number. Now what is basically conjugate? So every complex number has associated with another complex number known as its complex conjugate. You find the complex conjugate simply by changing the sign of the imaginary part of the complex number. Now in order to calculate a conjugate of a number, okay, what you do is you just change the sign of the imaginary part. That's how you calculate a conjugate. Now there is an example written out here. To find the complex conjugate of 4 plus 7 iota, we change the sign of the imaginary part. Thus the complex conjugate of 4 plus 7 iota is 4 minus 7 iota. So that's how easy it is to find out the conjugate of a complex number. Now okay, now I have given a example and I want you all to solve it with me. It says that, okay, now first of all, z plus z bar is equals to twice of real of z, and z minus z bar is equals to 2 times imaginary of z if z is a complex number. Now what they're trying to tell you out here. Okay, first of all, the complex, when you say that you will be calculating conjugate. Now how we will know that we need to find out the conjugate if conjugate itself the word is not written. So symbolical representation of conjugate is z bar, okay. So see, z bar, any complex number, okay, if it's associated with any sort of name and it has a bar on its top, which means that they are asking you to find out its conjugate, okay. So out here it says that what if I add if I take a number z, okay, it's and I take its conjugate as well. Then if I add them, the result will give me twice of the real part. Okay, and if I subtract those two things, that is first the number, the complex number itself, and its conjugate, so it will give me twice of the imaginary part. So how this thing is, okay, now let a z is equals to a plus iota b. Now out here I am giving you very general example. You can solve it with any non-general example. Okay, let z is equals to a plus iota b. What will be the conjugate? Conjugate means we just change the sign of the imaginary part. If it's plus, we substitute it with minus. If it is minus, we will be writing it plus. So z bar means z is equals to a minus iota b. Okay, now what we have to prove first? We will be proving that if we add these two things, the result will be somewhat twice of real of z. Okay, so how this thing is done? So what you're going to do is that you're just going to add these two numbers, right? Z and its the complex number itself and its conjugate. We're going to add these two things. Okay, what will be the result and how the operations are performed? The operations are the same as we do it as we have learned earlier. Okay, now as you can see, a plus a remains as it is. Okay, this is plus iota b and this is minus iota b, so these two numbers cancelled. What is the answer? A plus a, which gives you what? 2a. Okay, so that means twice of a real number. Re of z means that it's saying that if you have the result will be a real number z, real number of z actually. Okay, and twice of that real number, the result will be like twice of that particular real number. Now out here, if you just look at it, z, this number z, this number has real part equals to a. Okay, and the result says that the final answer will be twice of the real number. Now if the real number is a, so twice of the real number will be 2a, right? So that is how we prove this thing, that if we add a complex number to its conjugate, with its conjugate, the result will be twice of that real, twice of the real part of that number. Okay, moving on. Okay, out here now I'm going to take some real examples, some non-general example. Out here I have written z is equals to 5 plus 9 iota. Okay, now here a equals to 5 and b is equals to 9 iota, right? Okay, now the z bar means what? The conjugate is 5 minus 9 iota. Okay, now if I just add these two numbers, what will happen? Now as you can see, 5 plus 9 iota plus 5 minus 9 iota, this positive 9 and negative 9 cancels. Okay, they both cancelled. Now what remains? 5 plus 5 is twice of 5, right, which is equals to 10. Or you say twice of 5, 2 of 5. See, the logic was that twice of that real number. If the real number was 5, twice of 5, 2 of 5, that will be 10. Twice of that real number, 2 of a. So that is what we need to prove. Okay, if now another thing, let z is equals to a plus iota b and z bar or conjugate is a minus iota b, and we have to prove this thing. Now what will be the answer? Twice of the imaginary of z. Now whatever number the imaginary thing is written, whatever number the imaginary part have, the result will be twice of it. Okay, so z minus z bar will be a plus iota b minus of a minus iota b. So what I have done here is I've just multiplied this sign with this bracket. So this is minus a, minus into minus is plus. So a plus iota b minus a plus iota b. Now as you can see, this positive and this is negative, so the both cancels. What remains? plus iota b, which gives you what? 2 iota b. Alright, so this is how it works. Let's just take another example. Let's say z is equals to 4 minus 8 iota. Alright, and out here a is 4 and b is 8 minus 8 iota. Now why b is minus 8 iota? B is basically, if you just look at the complex number itself, it says complex number is a combination of both a real and imaginary part, right? And b was representing an imaginary part because iota was associated with it, right? So b out here is minus 8 iota. Alright, if you just go through the theorem, if you just go through what we understood or we have learned up till now, it says the result will be twice of the imaginary part of z, right? That means if the imaginary part represents b, okay, the imaginary part represents b in complex number, so twice of b means the result will be 16 minus 16 iota. Now let's see if this thing proves or not. Let z bar is equals to 4 plus iota. Obviously we're finding its conjugate. Okay, now what proof? Now we are proving z minus z bar is equals to twice of imaginary of z. That means that imaginary part of z. Okay, 4 minus 8 iota minus 4 plus 8 iota. What I have done in this particular step is that I have just multiplied this minus with this bracket. So minus 4 plus into minus gives you what? Minus. Now as you can see, this is positive and this 4 comes with a negative sign. So they both cancels, right? What remains? Minus 8 iota and minus 8 iota. Which gives you what? Minus into minus is plus, so minus 8 will be minus 16 iota, which is equals to, if you just say according to the theorem, according to the statement that we need to prove, which says twice of imaginary of z. Imaginary of z is represented by b, that is minus 8 iota. So twice of minus 8 iota, that is what we proved out here. Twice of minus 8 iota is minus 16 iota. Alright. Okay. So now we are moving on to the division of complex numbers. Okay. Now in this part, what I'm going to do is that I've taken this example directly and I will be telling you how to divide a complex numbers. Two complex numbers. Okay, let's suppose we have two complex numbers, and if we need to divide them, we will be writing them like this. This is my first complex number, this is my second complex number. I need to divide them both. Okay, now how should I divide them? Now to divide complex number, you multiply the conjugate. You must multiply by the conjugate to find the conjugate of a complex number. All you have to do is change the sign between the two terms in the denominator. Now what does that mean? Okay, first of all, the first thing when we are dividing something like this is that we need to solve this denominator first. Why? Because it's written in a complex way where it cannot be breaked easily, right? Without performing certain operation, we cannot resolve this part, denominator, and you know this remaining it like that and just solving it there are methods for that, but particularly the most easiest method is when you have a situation like this. What you do is you just take the conjugate of the denominator, okay, and rationalize the term. How? Okay, see, the conjugate of this particular number will be 4 plus 3 iota. Okay, 4 plus 3 iota. So what I'm going to do is that I'm going to multiply this term with its numerator and its denominator like this. Now if you just look at it, I'm resolving this 4 minus 3 iota. Okay, so I multiply this whole term with its conjugate. Okay, so this numerator is also multiplied with its conjugate, the denominator is also multiplied with its conjugate. So you can write it in this form. This is what we call rationalization, right? Okay, now if you just go back a little, this was my number. Now what I'm going to do is, since numerator two numbers are multiplying and denominators two numbers are multiplying, right? So what I did is I just followed basic multiplication rule, right? 12 plus 9 iota plus 6 iota plus 8 iota square. So I want you all to just multiply the numbers and the final result will look like something like this, right? Okay, if you just look at it, in the denominator, plus 12 iota and minus 12 iota, they cancels, they both cancelled. What remains? And if we just substitute iota square by minus 1 in numerator and in denominator, so what we will get, 16 minus 9, sorry 16, this cancels, okay, 16 minus into minus is what, plus, so 16 plus 9, 12 minus 6, 9 plus 8 is 17. So if you just solve it, 12 minus 6 is 6 plus 17 iota as it is, 6 plus 9 is 20. Learning how to calculate modulus of a complex number. Now modulus of a complex number, okay, so modulus or magnitude or absolute value of a complex number z is equals to x plus iota y is equals to x comma y is a non-negative square root of x square plus y square, and is called the modulus or absolute value of z or x plus iota y. Now what does that mean? Now when we are talking about the modulus or the absolute values, what we are going to say, what we are going to do is, out here as you can see it's written non-negative square root, right? That means we cannot include iota in it, because if I do it, it will eventually, what happen is this positive sign will convert into negative, and I don't want that. Alright, if I just include iota in the modulus, so it's an absolute value that includes only the positive, the non-negative numbers, or you say that includes the real number and real numbers in complex number. And you know that there are two real number, one the real number written as it is, and the second real number is actually associated with the iota, through which we say that it's an imaginary number because iota was associated with that number. But particularly if you just look at the definition or go through that again, it says that b and a are both real numbers and I is the imaginary unit, right? But when we are particularly calculating modulus, we don't need that iota, we don't need that imaginary unit, right? So modulus of a complex number z is equals to x plus iota y is denoted by mod of z or a mod of z, or this is the way how you just these are for a few representations of how you can write modulus of z. Okay, now how we calculate it? For example, okay, let's say z is equals to 6 plus 8 iota and I need to calculate mod of z, right? So how to calculate this? Now first of all what I'm going to do is z is equals to 6 square. It says real part is square and only the imaginary part but not the iota. Okay, we are not talking about iota, only the imaginary part that has without iota. So 6 plus 8, so this will be 6 square, alright, plus 8 square, which gives you a modulus of 100 is equals to 10. Now iota is not included. Let's say if I just include iota, right, so it will be 8 iota square, and I know that iota square is substituted like into -1. So if I do that, I end up making it complex rather than just finding its absolute or its magnitude. Magnitudes are positive values, they are not negative. Okay, So I hope you understood the complex number part out here, and I hope that you will solve the questions given. Meanwhile, I'll see you next time. Thank you.